Hello, everyone. We are going to continue with section 3.3 by discussing the last learning objective, perform dilution calculations using the dilution equation. The reason I wanted to separate this section into two parts was partly because the molarity concept is going to be another big concept we'll see throughout this semester, and I wanted to make sure you feel comfortable with that before moving on to the next part. The other thing is that this might be the thing from this class that you use the most. Those of you going into, say, biology courses will be using the dilution equation extensively, and it is used very often in research. So any of you who go on to do any type of undergraduate research, whether it's biology or chemistry, will be doing a lot with this equation. So it's not necessarily a big focus of this course, but it could be a big focus for you and how you apply this course. Not that it's unimportant for the course, but in terms of the importance of this course compared to the importance of the rest of your life, this one might be higher on the rest of your life scale. So let's go ahead and discuss the dilution equation. So I'm going to go ahead and kind of skip ahead to where this shows up, which is down here. So the dilution is a process that we use to take a more concentrated solution and make a less concentrated solution from it. We're showing a picture here of what this might look like. So here we're showing a solution that has a solute that's giving it a bluish color. And when we dilute it by adding solvent to it, we can see the volume of it increases. But we also see that the color is more moderate here than it is over here. Because we have less solute relative to solvent once we have done the dilution. Dilution is very important for many reasons. We can have maybe one solution of a higher concentration and make whatever concentration we need from it. So that's very useful to be able to do that. And then sometimes we want several solutions of varying concentrations, and so we need to be able to figure out how we go about doing that. This is something we'll be doing quite a bit in the lab. When I said the rest of your life, that also includes the rest of the lab we're doing. So dilution comes up a lot in chemistry labs, both this semester and next semester. So it's something we'll be doing quite a bit of, so it's something you want to make sure you're comfortable with. This is the derivation of the dilution equation, and I don't want to focus too much on the derivation, but the idea here is how this comes about is we can say moles is equal to concentration times volume, where we have concentration as molarity, so moles per liter. So moles per liter times volume equals moles. So pretty straightforward there. If we have two different solutions, we can say, okay, well, for this solution, its concentration times its volume is moles. Same thing for this one. And then what we can say is if those are basically the same except for the dilution process, so if we're using the dilution process to get from one to the other, what that means is that the amount of solute doesn't change. So the moles of solvent, and we're using N here to show moles of solvent, is the same from N1 to N2. Then we can write it in this way. Okay, so what we're saying is molarity of one solution, and we're using a subscript to indicate this is one, so we're going to call this solution 1 times volume of solution 1 in liters is equal to molarity of solution 2 times volume of solution 2 in liters. So this is kind of a derivation of the idea. We can do this with any concentration, any volume. And so we're putting it more generally here in terms of concentration instead of molarity. These are essentially these two equations. Let me go ahead and outline these. So this equation and this equation are the same thing. They are exactly the same thing. Where you might have maybe the second one instead of the first one is if you have maybe your volume is in milliliters instead of liters, or you have other units of concentration, and we'll talk about those shortly. Most of the time you'll be using molarity, but you could use this for another concentration as well. And you would be basically doing it the same way. So there's this relationship between concentration and volume as we perform a dilution. And essentially what happens, and we can actually even see that from the picture up here, is that as the concentration from here to here goes down, and we can see that because the color becomes more moderate, the volume goes up. Okay, the volume goes up. And so as you add the solvent to the solution, the relative concentration of the solution goes down while the volume goes up. Okay, and mathematically that's what this is showing, and we call this an inverse relationship. Now, in terms of really remembering that, you don't have to remember inverse relationship right now, but that's a concept we'll be coming back in this course with a future section, and it's a similar relationship. So if you recognize that now, it will be helpful a bit later. So a couple of things about getting some practice with this. There's a simulation here that I recommend looking at in terms of seeing how, as you make those changes, how changing volume affects the concentration, if that description wasn't as helpful to you. And then some examples here as well. Definitely recommend doing at least a couple of these. Look at the information you're given, try to solve the problem, and then look at the solution, as opposed to looking at the solution first. So I'm going to skip past the solution. So a few examples of this. I would, if you need to look at one before doing the other, that's fine, but make sure you're getting some practice with this. So it looks like we have 3 examples there of using the dilution equation. So look at those. There will be, again, worksheet questions about this, so make sure you're looking at those. And then please ask if you have questions, and we can, I can share some videos with you of going through the solution process if you find that more helpful. So this is the end of section 3.3. We have a little bit left to go in the module, so please move on to section 3.4 when you're ready.